Astronomy, from Greek astronomia, is a natural science that studies celestial objects and phenomena. It uses mathematics, physics, and chemistry in order to explain their origin and evolution. Objects of interest include planets, moons, stars, nebulae, galaxies, and comets. Relevant phenomena include supernova explosions, gamma ray bursts, quasars, blazars, pulsars, and cosmic microwave background radiation. More generally, astronomy studies everything that originates outside Earth's atmosphere. Cosmology is a branch of astronomy. It studies the universe as a whole. Astronomy is one of the oldest natural sciences. The early civilizations in recorded history made methodical observations of the night sky. These include the Babylonians, Greeks, Indians, Egyptians, Chinese, Maya, and many ancient indigenous peoples of the Americas. In the past, astronomy included disciplines as diverse as astrometry, celestial navigation, observational astronomy, and the making of calendars. Nowadays, professional astronomy is often said to be the same as astrophysics. Professional astronomy is split into observational and theoretical branches. Observational astronomy is focused on acquiring data from observations of astronomical objects. This data is then analyzed using basic principles of physics. Theoretical astronomy is oriented toward the development of computer or analytical models to describe astronomical objects and phenomena. These two fields complement each other. Theoretical astronomy seeks to explain observational results, and observations are used to confirm theoretical results. Astronomy is one of the few sciences in which amateurs play an active role. This is especially true for the discovery and observations of transient events. Amateur astronomers have helped with many important discoveries, such as finding new comets. Etymology: astronomy, from the Greek astronomia, from astron, star, and nomiam, from nomos, law or rule, means study of celestial objects. Astronomy should not be confused with astrology, the belief system which claims that human affairs are correlated with the positions of celestial objects. The two fields share a common origin but became distinct, astronomy being supported by physics while astrology is not. Use of the terms astronomy and astrophysics. Astronomy and astrophysics are broadly synonymous in modern usage. In dictionary definitions, astronomy is the study of objects and matter outside the Earth's atmosphere and of their physical and chemical properties, while astrophysics is the branch of astronomy dealing with the behavior, physical properties, and dynamic processes of celestial objects and phenomena. Sometimes, as in the introduction of the introductory textbook, The Physical Universe by Frank Shu, astronomy means the qualitative study of the subject, whereas astrophysics is the physics-oriented version of the subject. Some fields, such as astrometry, are in this sense purely astronomy rather than astrophysics. Research departments may use astronomy and astrophysics according to whether the department is historically affiliated with a physics department, and many professional astronomers have physics rather than astronomy degrees. Thus, in modern use, the two terms are often used interchangeably. History: prehistoric. The initial development of astronomy was driven by practical needs like agricultural calendars. Before recorded history, archaeological sites such as Stonehenge, provide evidence of ancient interest in astronomical observations. Evidence also comes from artifacts such as the Nebra Sky disk, which serves an astronomical calendar defining a year as 12 lunar months, 354 days with intercalary months to make up the solar year. The disk is inlaid with symbols interpreted as a sun, moon, and stars, including a cluster of 7 stars. Classical civilizations such as Egypt, Mesopotamia, Greece, India, China, together with cross-cultural influences, created astronomical observatories and developed ideas on the nature of the universe, along with calendars and astronomical instruments. A key early development was the beginning of mathematical and scientific astronomy among the Babylonians, laying the foundations for astronomical traditions in other civilizations. The Babylonians discovered that lunar eclipses recurred in the Saros cycle of 223 synodic months. Following the Babylonians, significant advances were made in ancient Greece and the Hellenistic world. Greek astronomy sought a rational physical explanation for celestial phenomena. In the 3rd century BC, Aristarchus of Samos estimated the size and distance of the moon and sun, and he proposed a model of the solar system where the Earth and planets rotated around the sun, now called the heliocentric model. In the 2nd century BC, Hipparchus calculated the size and distance of the moon and invented the earliest known astronomical devices such as the astrolabe. He also observed a small drift in the positions of the equinoxes and the solstices with respect to the fixed stars that we now know is caused by precession. Hipparchus also created a catalog of 1020 stars, and most of the constellations of the northern hemisphere derive from Greek astronomy. The Antikythera mechanism, around 150 to 80 BC, was an early analog computer designed to calculate the location of the sun, moon, and planets for a given date. Technological artifacts of similar complexity did not reappear until the 14th century, when mechanical astronomical clocks appeared in Europe. After the classical Greek era, astronomy was dominated by the geocentric model of the universe or the Ptolemaic system, named after Claudius Ptolemy. His 13-volume astronomy work, named the Almagest in its Arabic translation, became the primary reference for over 1,000 years. In this system, the Earth was believed to be the center of the universe, with the sun, the moon, and the stars rotating around it. While the system would eventually be discredited, it gave the most accurate predictions for the positions of astronomical bodies available at that time.